Hi everybody, welcome to day 4 of Unit 5. We're going to be talking today about sequences, in particular arithmetic and geometric sequences. Today we're going to talk first about arithmetic sequences. Arithmetic sequences are found by adding and or subtracting a number from the previous term. A common difference, this would be the number that is added or subtracted to an arithmetic sequence. The term here, it's going to be f of n is equal to f of 1, which would be our starting value, plus the d, which is the common difference, multiplied by n minus 1. Or, this is how you normally would see it, a sub n is equal to a sub 1 plus d times n minus 1. So we're going to use that particular piece. Or geometric sequence, this is found by multiplying or dividing the previous term by a number. Now, unlike the last one, we're multiplying and dividing here, not adding and subtracting. That's what makes it a geometric sequence. And instead of finding a common difference, we need to find what's called a common ratio. This is the number that is multiplied or divided in a geometric sequence. Now, the equation f of n is equal to f of 1 times r, some ratio raised to the n minus 1, or better yet, this is how it normally would look, a sub n is equal to a sub 1, the starting term, times your ratio raised to the n minus 1. So for this first one, we're going to try to determine if the sequence is arithmetic or geometric, and then find the common ratio common difference or ratio and the next three terms. So looking at problem number 1. Problem number 1 is starting at saying 17, then it goes to 14, then it goes to 11, then to 8, to the 5. This is an arithmetic. It is an arithmetic sequence because we are subtracting. We're subtracting 3 each time. The common difference, or ratio, this one has a difference, and that difference is minus 3. So, with this particular thing in place, sorry, that kind of slid on us there, the next 3 terms, well, keep subtracting 3. This one's going to be 2, the next one will be negative 1, and then minus 3 again, you're going to get negative 4. So those would be your next 3 terms. Number two is a little bit different in that now it's starting at 160. It's going down to 80, then down to 40, then down to 20. This one, the type here, well, this is a geometric. And it is a geometric because we are dividing everything by 2. This has a ratio. And so we are dividing everything by 2. Or another way of saying that, multiply by 1/2. Either way, you're going to get to the same answer. So if we keep dividing by 2, 20 divided by 2, that's 10. 10 divided by 2, that's 5. 5 divided by 2, well, that's 5 over 2. That would be the solution to this one. Now, let's go to this next one. Looking at this next one, it's saying negative 10, negative 7, negative 4, and negative 1. So what type would this be? Well, it looks to me like we're just going up by 3 each time. So we have a arithmetic again. This is a difference situation, not a ratio. And our difference in this one is going to be plus 3. So we're adding 3 to each previous value. That makes this next one, negative 1 plus 3, that's 2. Plus 3 again, that's 5. Plus 3 again, That is 8. So we end up with a sequence that runs like that. The dots here mean it goes on forever. Let's take a look at this next one, number 4. This one's starting at 1, it's going to 4, then to 16, then to 64, then to 256. This one is a geometric This one has a ratio here, and the ratio that we're going to be dealing with here, we are multiplying by 4. So we take each previous term and we multiply by 4. So at this point, 256, we're going to multiply that by 4, we're going to get 1024. We're going to take 1024 and we're going to multiply that by 4, we get 4096. And we're going to take that term of 4096 and we're going to multiply by 4 again, we're going to get 16384. And so that would be the terms here. Let me change that, it's a little ugly, 384. Hopefully that makes sense in terms of what we're trying to do. So there are 2 questions right here, A and B. I would like you to do those right now. I will stop the recording, so make sure that you pause and do those 2 problems, and then come back. I'll come back and I'll put the answers up and we'll test them. Make sure that you pause. All right, so there should have been your answers. First one was an arithmetic, second one was a geometric, and we would have 17, 20, and 23, 32, 64, and 128. First one's a difference, second one's was a ratio, and then you just work them out. So now this next part, it's saying what they want us to do is write the first 4 terms of each sequence starting with n equals 1. And so they're showing us this particular one, and they're saying that they want us to start with 1 and write the first 4 sequences. So f of 1 is equal to, then everywhere you see n, you plug in 1. So 1 minus 1 squared. Well, that's going to be 0 squared. The next one, f of 2. Everywhere you see an n, you plug in 2. So 2 minus 1 squared, that's going to be 1 squared. Sorry about that, the bell was ringing. Next one, f of 3, that's going to equal 3 minus 1, we're going to square that. That's going to be 2 squared, that's going to give us 4. Sorry, I forgot to finish these up here. This is 1, this is 0. And then the last one, f of 4, that's going to be 4 minus 1 squared. Well, that's going to be 3 squared, which is 9. So that would be those particular ones. Now, they want you to do the same thing here on C, so I'm going to give you a second to do that. I will come back in just a moment and show the answers. You need to stop the recording and actually try it before you do it, so press pause. All right, here should have been your answers. F of 1 was 1/2, f of 2 ended up being 3/5, f of 3 ends up being 2/3, and f of 4 is equal to 5/7. Make sure that you are simplifying your fractions to their simplest form. All right, this next one. This next one is talking about a word problem, and it's saying at the beginning of the year, Jason had $40 in the savings account. He plans to deposit $20 into his account each month. By the end of January, he will have $60, by $80 by the end of February, $100 by the end of March, and so on. Which equation describes the amount A sub m, or A of m, that his savings will have grown in any given month? So, is this going to be an arithmetic or geometric? Well, this one is going to be an arithmetic, because all we're doing is adding 20 to each prior month. We're going to start with 40, and then we're going to add 20. And since we don't know exactly which month it is, this right here would be our answer, because it depends on the month. If we talk about 5 months from now, we plug in 5, we'd get $100 plus 40, it'd be 140. So that would be our total 5 months down the road. Hopefully that makes sense. This last part, we're going to talk a little bit of vocabulary here. A function in the form of f of x is equal to a sub x, this would be considered a linear function. A function in the form of f of x equals ax squared, this is what we would call a quadratic function, and a function in the form f of x is equal to a to the x, we would consider this one to be called an exponential. Oops, gotta learn how to spell some days. Exponential. So, in terms of those three functions, we're going to talk about the difference of them in terms of how they grow. So, we're going to use this table to help us determine which function has the greatest value of x gets larger and larger. So, looking at this one, the first one, this is a linear. We've done this before. This is kind of an mx plus b. So, we're going to say f of 3 is equal to, everywhere you see x, you plug in a 3. 3 plus 3, that equals 6. Next one, f of 4. Everywhere you see an x, you plug in 4. So this would be 4 plus 3. This is going to be 7. F of 5. Everywhere you see an x, you plug in 5. This is 5 plus 3, that is 8. 8's are a little bad. Let's try that again. 8. And then the last one, f of 6, that's going to equal 6 plus 3, that equals 9. So those are the values for these particular ones when you're talking about a linear function. Now let's go on to a linear function that isn't having something added to it, it's actually having something multiplied. So we've got an mx situation here. But the process is going to be exactly the same as what we were doing before. So this is going to say g of, and then we start using our x values. This is 3. That makes this 3 times 3, that's 9. G of 4, everywhere you see an x, plug in the number. This is 4, that's going to be a 12. G of 5, 3 times 5, that's going to be 15. And g of 6, this is going to be 3 times 6 equals 18. So this one growing a little bit faster than the last one. How about this next one though? Next one, this is a squared function, x squared. So this is a quadratic. So as we grow this one, we're going to see what happens. This is h of, start with a 3. Well, it's going to be 3 squared, that equals 9. That's just like the last one. H of 4, well, that's going to be 4 squared. Well, that's equal to 16. That's getting bigger now and a little bit quicker. H of 5, well, that's going to be 5 squared. That's 25. And when we say h of 6, then it is 6 squared. That gives us 36. So as we can see, this one is growing faster than the other two. And then our last one, this is the exponential function. The exponential function, it says I to the 3. So now we're going to replace every x with a 3. Well, 3 to the third, that means 3 times 3 times 3, that is 27. Then I to the fourth, or I of 4. That's going to be 3 to the fourth. Well, 3 to the fourth would be one more 3 than the previous one. That's 81. I to the fifth. Well, that's going to be 3 to the fifth. So that's 3 times the previous answer, which is 243. And then the last one, I of 6. That's going to be 3 to the 6th power. That's 3 times the last answer, which is 729. And so that shows that this last one, the exponential, that's the one that's really going to grow a lot faster. And that will be the fastest growing one that we see. And then this last problem, it says, which of the following best describes this table of data? So we have a 1 to 3, we have a 2 raising to a 9, a 3 to a 27, a 4 to a 81. This looks to me like it is a geometric problem. It's growing. If we look at our y's are growing by 3, then by 3, then by 3 again. So if I were to plug in a 5, we'd grow by another 3 being multiplied. So this is going to be an exponential problem. And there's only one exponential problem here. That is this one. That would be A, so that's the one that we're going to be using right for this one. Just get this pen to work. So our answer to this one is going to be A. It's just not letting me do A, so I'm just going to do my best to shade this one. It's not going to let me choose A. The answer to this one is A. I don't know why my page is not allowing that. So just so we're clear, the answer is A. Let me do it this way. Maybe I can get it this way. A. All right, that's it for today. Have a great day, and we'll talk to you soon. Bye.